In this lecture, we're going to discuss connective tissues. These are going to be divided into two main groups. The differences are going to be the types of cells that we find and the components of the extracellular matrix. So first we have connective tissue propers, and then we have specialized connective tissues as well. The connective tissues that we're going to discuss, the cells in the extracellular matrix, they're similar to what we see in the epithelial tissues, the muscle tissues, the nervous tissues, in that we have some similar characteristics. The extracellular matrix, we didn't really see a whole lot of it, didn't really mention a whole lot of it in epithelial tissues, and we're not really going to mention a whole lot about it in muscle and nervous tissue. However, for connective tissue, the extracellular matrix, that's like where it is. That's the main characteristic. That's the main feature to distinguish each of these types of tissues. It also plays a big role in the function of each specific type of connective tissue as well. Now, what we're not going to see in connective tissue, like we did in epithelial tissue, is we're not going to have an apical surface, and we're not going to have a basement membrane. So although we do have some similar characteristics, we also have some really big differences that are going to help us distinguish as well. So, connective tissues, we have a few main functions here, and they're a little all over the place. They do quite a few different things. We connect and bind. Okay, so anchor tissue layers in organs, hold organs in place. We just kind of connect your body to itself. We have supportive functions. Your bones and your cartilages specifically help support the weight of your body. We have protection, so your bones protect your internal organs. For example, your skull protects your brain. We also have cartilages and fat that provide shock absorption every time we move. And then transport. So your blood, for example, transports nutrients, oxygen, waste products through the blood itself throughout your body. So our functions are a little all over the place here. So we mentioned that we have two main categories, our first being connective tissue proper. Sometimes these are also referred to as general connective tissues. So whatever terms you prefer. Okay. You find these very widely distributed throughout the body. These are the ones that are going to connect your tissues and organs to each other, and it also provides an internal architecture for some organs. Okay. Some of the cells that we're going to see over and over and over, we've got fibroblasts, adipocytes, mast cells, phagocytes, and even some other immune system cells as well. So first we have fibroblasts. These are the most common cell type that you're going to find in the connective tissue propers. Okay? And that's because of their function. If you remember back to the protein fibers that we've mentioned previously, the collagen fibers, the reticular fibers, the elastic fibers, somebody has to make those, and that's what fibroblasts do. They make fibers. They also make the ground substance, which is one of those components of the extracellular matrix. Okay. So fibroblasts are always working hard to produce collagen proteins and the ground substance and all that kind of good stuff. So here is a nice example of a good-sized fibroblast, a very prominent nucleus, and then you can see all these thick collagen fibers that are surrounding the cells. And then all of this space that almost looks clear or really pale, that is your extracellular matrix. Our next cell type is adipocytes. This is your adipose or your fat cells. Okay. You don't just find this by itself. Okay. You find adipocytes in a lot of different connective tissues. Adipocytes themselves, each of these cells individually is an adipocyte. The majority of the cell is what we call a lipid inclusion molecule, and that is a fancy word for fat. That's your fat, y'all. But these are legitimate cells. Okay, they have a nucleus, they have cytoplasm. It's just a little bit more difficult to see because the lipid inclusion gets so large. Okay, so again, each of these are a legitimate cell by themselves. Okay, they have the full components. All we really just end up seeing is the lipid inclusion there. Mast cells are the largest cell type that you are liable to see in connective tissue propers. They are filled with granules. So each of these big blue dots, these are granules. Okay, and the big purple thing is the nucleus in the center. These granules, and we have a lot of them, okay, these contain inflammatory mediators, and the one that may be somewhat familiar to you is histamine. Okay. If we are opening these granules and releasing that histamine, this is going to cause inflammation. Okay. Inflammation is a response from your immune system to help fight, foreign invaders or whatever is going on inside your body. Histamine may or may not be familiar to you if you suffer from allergies, because one type of allergy medication are known as antihistamines. Okay, so again, this term may be familiar to you, but this is where some of that histamine comes from, these mast cells. It's not the only place, but it is one of the places. All right, then we have phagocytes. Okay, so your body, your immune system specifically, we have a couple of different types of phagocytes. For the histology lecture, we're just going to keep it very basic and kind of collectively call them phagocytes. They are immune system cells. They literally eat foreign substances, bacteria. They can even eat dead cells, damaged cells, things like that. They do that through phagocytosis. So phago means to eat, and a cyte is a cell. So we're going to eat cells. Two main types are macrophages and neutrophils. These are specific types of immune cells that when you get to the immune system lectures, you'll go into a lot more detail about. So for right here, we're just providing examples. Macrophages and neutrophils, they are phagocytes. They can consume, foreign cells and things like that. And that's just an example. They kind of look a little funny, a little wild with their little pseudopods. And these little red things, these are the bacteria that we're going to eat up. Now we have 4 basic types of connective tissue proper, and then 3 basic types of fibers that we've already mentioned. So we're going to see these over and over and over. So our 4 basic types of connective tissue proper, we've got loose and dense connective tissue, we've got reticular tissue, and we've got adipose tissue. Okay, the collagen fibers, the elastic fibers, the reticular fibers, we've mentioned those previously, but these are going to come up over and over and over in several of these tissues as well. Collagen, these most often stain like a pink or red color. They're usually pretty thick. Elastic fibers are very wavy, and they usually stain black. And then reticular fibers, they usually also stain black, but they're usually not very wavy, and you usually don't see as many of them unless we're talking about reticular tissue specifically. So, first of all, we have loose areolar connective tissue. And just like we talked about in epithelial tissues, the naming was very important, making sure you get the layer and the cell shape in the name. Here, we need to make sure that we're not leaving off parts of these names. So areolar connective tissue is not the full name of this. It's loose areolar connective tissue, okay? Just kind of throwing that out there. So this is mostly ground substance, so you'll see a lot of quote-unquote empty space, okay, within these tissues. You do find all 3 fiber types. You find fibroblasts very readily. Every once in a while you'll see an adipocyte. Probably more often you won't, but they could be there. And then everything is kind of suspended in the ground substance that we've mentioned previously. So these big funny shaped cells, these are your fibroblasts. Okay, our big thick pink fibers, those are our collagens. These thinner ones are your reticular fibers. These really wavy ones are going to be your elastic fibers. Okay, we find these beneath your skin, the epithelial layer of your skin, membranes lining your body cavities within hollow organs themselves. So this is a fairly prevalent tissue. Then we have dense fibrous connective tissue. This comes in two varieties, dense irregular and dense regular connective tissue. This is mostly protein fibers, okay, specifically mostly collagen fibers. You've got dense irregular connective tissue where those collagen fibers are just kind of all over the place. They're disorganized, okay. This allows for strength and resistance to tension in all three planes of movement. Okay, so X, Y, and Z plane, I guess. Whatever you call it. So not just a forward and a backward, not just an up and a down, but like a three-dimensional movement. These are, or this is found predominantly in your dermis of your skin, and it also surrounds your organs and your joints. Okay, so think about your skin. You can tug on your skin. You can move your skin somewhat in multiple planes of movement. Your dense regular connective tissue, all this pink is still collagen fibers, but now you notice that those collagen fibers, they are very organized now. They run parallel to each other. These help with resistance and tension in one plane of direction instead. Okay, so if you can imagine pulling on this from both ends, okay, or top and bottom, okay, probably end to end though. These, besides your tendons, you also find these in ligaments, okay, and your tendons and ligaments are really only good in one plane of movement, okay, and so there's a lot of form meets function there. You still have a lot of fibroblast activity. Somebody has to crank out all these collagen fibers. And then we have dense elastic connective tissue. Okay, so instead of a bunch of collagen fibers, now we have a ton of elastic fibers, and we've mentioned that those are usually stained black and that they are very wavy. These fibers also are much more organized than the dense irregular connective tissue. Okay, you find these in places that have a lot of stretching. Okay, so your blood vessels, certain ligaments as well, but your aorta is usually a very common example of where you find a lot of these elastic tissues. Now, reticular tissue. Okay, so we don't normally see a whole lot of reticular fibers except in reticular tissue. Okay, we don't forget that it is still produced by the fibroblasts. Okay, and that's who's cranking out all of these fibers. Here we could just call them reticular cells instead. It's the same function. We have another form meets function here. You create these webs. Okay, see how this is kind of almost spider-like? Spider web-like, I should say, not spider itself, spider web. It's really good for trapping things. Okay, so any organ that does a lot of filtration, like your lymph nodes and your spleen, that's where you're going to find a lot of this reticular tissue. It also forms part of the basement membrane of your epithelial tissues, some of the internal structures of your liver and your bone marrow as well, which your liver does a lot of filtration, and your bone marrow does a lot of cell production and things like that. So that's one of the common places that you find reticular tissues. Okay. Notice that we also have, in this particular example, a lot of leukocytes that are trapped within our spider web. These white blood cells, as your lymph nodes in your spleen filter your lymph, your blood, things like that, we're trapping the bacteria in our spider web, and then these white blood cells can attack those foreign invaders. Now your adipose tissue, we've got tons of adipocytes here. That should make sense to you. We've mentioned previously that adipocytes are mostly composed of the lipid inclusion, but we do still have the nuclei in the cytoplasm. It's just they're just not as easily seen. These are found deep to your skin. We call it subcutaneous fat. But let's be honest, we don't have to necessarily look very hard for adipose. We've got it in your abdomen, breasts, hips, buttocks, thighs. We usually don't really have a hard time finding examples of adipocytes. Adipose that surrounds your heart and your abdominal organs, we call this visceral fat. And these adipocytes are used for energy storage, insulation, shock absorption, protection, things like that. Yeah. Okay, so now we're into our specialized connective tissues. They have, I like this definition, specialized connective tissue, more specific functions, right? Special, they're specific. So we have a couple types of cartilage we're going to talk about, and then we're going to mention bones and blood. So your cartilages. You do have multiple types of cartilage throughout your body. Collectively, they are tough yet flexible. They are good shock absorbers. They resist tension, compression, and shearing forces. So we have lots of forces. The extracellular matrix consists of a lot of collagen and elastic fibers. So we need strength and flexibility, as well as glycosaminoglycans and proteoglycans. And we've talked about those assisting with the buildup of fluid within the tissues to provide shock absorption, basically. You are going to find a lot of chondrocytes and chondroblasts within your cartilages instead of a lot of fibroblasts. So chondro means cartilage, basically. So chondroblasts, chondrocytes, cartilage. Okay. The chondroblasts are immature cells that do a lot of mitosis. And this is, you find a lot of these in your extracellular matrix. Eventually, the chondroblasts, instead of immature cells, they kind of grow up, and they mature, and they basically build themselves little houses. They call them lacunae or lacunae, however you prefer to pronounce that term. These are the little houses that the mature chondroblasts live in, and once they mature, we don't call them blasts anymore. Now we call them chondrocytes. Okay. Once they mature into chondrocytes and they live in their little houses, their little lacuna, they become inactive and they just kind of live in their little houses for the rest of their lives. Most of your cartilages are basically avascular. Okay, so the blood supply is coming from a different location, specifically an area called your perichondrium. So peri means around, so right around the cartilage itself. This is dense irregular connective tissue. So we talked about being avascular, and we talked about epithelial tissues, and we talked about how that really limits the thickness of the epithelial tissues, and it's the same with cartilage. So living cartilage is very thin because we have to diffuse our oxygen and nutrients from this perichondrium into the cartilage itself. And diffusion, you have a limited amount of distance that you can cover if you're only doing diffusion. So if you don't have direct blood supply, you're going to be a thinner tissue. And it also has implications as to how quickly and how well you can repair yourself if there is damage. So if you do have tissue damage, you need a lot of blood supply. You're going to need the oxygen, the nutrients. You're going to need to get repair substances to the site of damage, and that's really limited here in cartilages. So hyaline cartilage. Okay. This is the most abundant type of cartilage you have. We have a lot of ground substance here. And then you've got small bundles of fine collagen. This tends to have a glossy, bluish, grayish appearance. Okay, so here it's almost more of like a purplish shade, like a pinkish shade, but this is what we're talking about here. You find this in a couple of interesting places. First, on the ends of long bones. Now, you're going to hear this term again, articular cartilage. So articular cartilage is hyaline cartilage. But articular refers to articulations. It refers to your joints specifically. So at the ends of your long bones, your articulations, your joints, okay, we have a layer of this hyaline cartilage that helps reduce friction. We don't want bone-on-bone action. That's where you get arthritis and bad things like that. So that's one of the locations. So when we start talking about bones and we talk about joints, instead of calling it hyaline cartilage, we are just going to call it articular cartilage. So make sure you keep that term in the back of your mind. This links the sternum to the ribs. Okay. Framing for your respiratory tract, so your trachea. Okay. All of this blue stuff is your hyaline cartilage. And in your nose. Okay. So your nose is hyaline cartilage. Now, most of the fetal skeleton is hyaline cartilage. So as babies are created, okay, little tiny fetuses. You do not create bone out of thin air. You create bone from hyaline cartilage. Okay, so as a fetus develops, you replace hyaline cartilage with actual bone. And so by the time the baby is born, it's not 100% bone yet, but it is predominantly bone by the time it is born. And then we have fibrocartilage. We've got bundles of collagen fibers, fibrocartilage, collagen fibers, there we go. We've got a little bit of ground substance and extracellular matrix as well, but you can see these collagen bundles are fairly predominant here. Here's one of the places that you really see these chondrocytes in the lacuna. I didn't really mention those on the hyaline cartilage, but they're pretty obvious here as well. And I usually call these things eyeballs. I just think they kind of look like eyeballs, okay, with the white of the eye and then the iris of the eye. That's just kind of what I think they look like. Now these, because there's a little bit more room and there's a little bit more of that extracellular matrix in there, these are really good. They have a lot of tensile strength, and so you find these in places that are susceptible to a lot of compressive forces, like your intervertebral discs, and they basically just act like cushion. Okay, they act like cushions because, again, we don't want bone-on-bone action. That's where that arthritis comes from, and so we've just got different ways to prevent that friction there. And then we have elastic cartilage. Elastic cartilage, it will not shock you to learn, has a bunch of elastic fibers in the ECM. These are really good at recoil, so they do vibrations a lot. So anywhere that you need to either vibrate, to either hear things or to make your own sound, you're going to have a lot of elastic cartilage. So your external ear, okay, so the portion of your ear that you can touch and you can wiggle. And then your larynx is where you produce your own sound. Okay, so these are going to vibrate from those elastic fibers. Now, our specialized connective tissues that aren't cartilages, we've got bone. Okay, the bone extracellular matrix, we call it osteoid. Okay, the ground substance is called osteoid. You do also have collagen fibers in bone as well. The majority of the extracellular matrix is composed of calcium phosphate crystals. That's what gives bone its hardness. Okay. One of the things that's sometimes mind-blowing to students is the fact that bone is dynamic tissue, meaning it changes. Okay, it remodels itself all the time. And it doesn't just remodel when you have broken a bone. It's always remodeling itself based on our need for calcium. Okay, so if we don't have enough blood calcium, well, our bone has a bunch of calcium in it. Let's just go take some of that calcium out of our bones. If we have a lot of blood calcium, we could store some for later. We could put it back in our bones. So we have three types of cells that we'll see in the bone chapter as well. So we'll introduce them here. We've got osteoblasts. Blasts build bone. Okay, got lots of B's. Osteoblasts build bone. Osteocytes are mature bone cells that live in lacuna. So these are the cousins to the chondrocytes that live in lacuna and cartilage. Osteo means bone though. Chondro meant cartilage. And so they're cousins, but they're not the same thing. And then osteoclasts destroy bone, so they break it down. I say kind of osteoclasts chew up the bone. Okay, so blasts build the bone, clasts chew the bone. And this is our classic example of bone tissue. Okay, these little dark spots, these are our osteocytes in the lacuna. This dark circle in the middle, it's called a central canal. This is where your big blood vessels run, your nerve fibers, things like that. Osteoclasts are giant multinucleated cells. Remember, they're going to chew the bone. Osteoblasts are these thinner, smaller cells that build the bone matrix. And then the osteocytes are building, they've got their little lacuna around themselves. So this is also bone tissue, but this one is our classic example that we always show students. Okay. All right. Lastly, we have blood. This is our only extracellular matrix that is fluid. We know it as our plasma. you have quite a few things that float around in your plasma, the first being plasma proteins. These are not like the fibers that you have in the other connective tissues. These plasma proteins are a lot smaller. They have a lot of different functions. Some of them help transport substances, some of them help with blood clotting, some of them help with fluid regulation, lots of different functions there. In addition to those plasma proteins, we have three types of cells or cell fragments: erythrocytes and leukocytes. These are red cells and white cells respectively. Your erythrocytes transport oxygen throughout your body. Leukocytes are your immune system cells, and then platelets are technically just cell fragments. They are not complete cells themselves, and they play a role in blood clotting.